What are we coming up to right now?
These are called the tertiary filters.
Tertiary filters.
You know, after it's going through the primary sedimentation, then you go with the aeration basins, then you go to secondary sedimentation or clarification. That's where the water comes.
Check out this one. Whoa. Yeah, this one's...
See, that's the clarity of the water coming into the filter. If you imagine underneath there, you have a bed of sand, you have a bed of anthracite. It goes through that and gets...
What's anthracite?
Anthracite's coal.
Coal?
Coal. Yeah, a little piece of coal. It's called the mixed media bed, and that just further clarifies the water. And also, it's necessary for Title 22 water reclamation. Once the water leaves this plant, it's basically unrestricted use for reclamation, so you can do whatever you want to with it as far as that goes, as far as reclaiming it. But in order to make that claim, you have to have these type of filters working. When you see the real high quality of the water on top of this, eventually, you know, a little bit of head pressure builds up on top of it. We backwash this material back in the treatment plant and retreat it again. But in the meantime, it's going through the sand and the coal underneath here.
So it's just like a filter?
Yeah, it's a big filter.
Okay, cool. Well, why is it called tertiary?
Well, it's the final process. It's the final treatment process. There's nothing more going on after this except for, like I said, just adding a little chemical to disinfect it.
So this is almost ready to go back out?
Sure is.
Why does it still look so dirty?
Oh, this is just stuff floating around. This never goes through the water. You know, if you think of it in terms of here's the top of the glass, here's all this filter media right here. The stuff right here just gets cycled back in the plant.
And what happens with the stuff on top?
Well, it'll get retreated and get removed in some sort of physical process. Right here, this is the meter that measures the influent turbidity coming into the filters itself, and right now it's at 0.83. Our limit going out the plant is 2.0, and so that just shows you the high quality water that's coming to the filters, and that'll show you right afterwards how much the filters are able to remove this turbidity. But that's an excellent number.
So the lower the better? Or?
Oh yeah. So here's one filter that's online. We just keep the lights off to save energy around here.
That's cool.
You know, I could go on and on about, you know, how much effort we put into saving energy here at the facility. So nobody's really down here. This is all monitored on our computer system, which I'll show you a little bit later. There you go, 0.341 going out. Excellent water quality.
That's even better than the other one.
Absolutely. Well, it should be, because that's before the filters. This is as it's leaving the filter.
Oh, that's here. Incoming and that's outgoing?
Yeah. Oh. You know, all the filters are right up along the side here.
What is this? The workings of the?
Well, this is the pumping system here for the primary clarifiers that we just took a look at. And what we're doing is we're pumping the solids out. The material comes in, the solids settle at the bottom of the tank. We're pumping them over to our digesters right there.
Okay, and then the water goes somewhere else.
Well, the water goes to the process.
Oh, and then the solids go.
Yeah, the solids go back to the digester.
Here we go.
Gravity belt thickener, and that's taking that sludge from the aerobic process and basically taking it over here, pumping it over here, putting it on this belt, putting a little polymer in it to thicken it up a little bit so we can put it in the digesters. We don't want to overload the digesters with water. It's not healthy for them, so that's what we do with this particular process.
Digesting?
Yeah.
Anaerobic.
This is from the aerobic. Remember, it comes from the primaries. This is not primary sludge. This is sludge that comes from the aerobic process. So from those tanks. You know, the aerated tanks?
Yeah.
Okay. It essentially gets thickened at the bottom of those secondary clarifiers, then it gets pumped over here and thickened a little bit more, then it's pumped directly into the digesters. Now, if you can imagine, you know, as we're going through the treatment process, I've shown you a couple places where we're removing solids. You know, that solid portion, the waste stream that comes in, it ends up over here. You know, the water is essentially what leaves the plant. It's completely free of solids, or we're talking 1, maybe 1.5, 2 parts per million. Over here is where all the solids go, and essentially they get mixed in an anaerobic environment, which means no oxygen. Methane gas is created from that, and that's what we're hoping to harness here in the next few months, is we're going to have a plan to burn that gas off there. Currently we're flaring it. We're going to burn that gas and create more electricity.
Flaring it?
Yeah, it's basically set up a flare. I'll show it to you afterwards.
Okay.
Yeah.
So it doesn't build up pressure?
Well, yeah, exactly.
Okay.
So it's just being burnt to atmosphere, but it's a source of, you know, 400 to maybe 500 kW kilowatts, which is pretty significant here. You know, that represents probably 40% of the load during most times as it's stretched out over a 24-hour day. And so, you know, we'll be able to tap into that resource and use that.
So are we hearing the flaring going on right now? Is that what that is?
No, you don't hear the flare.
Those are just the pumps.
There's actually valves opening up as things are being pumped. They're just pneumatic valves, so, and it's getting pumped from 2 sources. One, the primary sludge comes in its own particular fashion, but also the processed material that comes in off the aeration tanks. Right. We solidify that quite a bit, and so we get 5 to 6% solids.
This is pretty cool. So we're standing on top of the
anaerobic digester number 1.
Anaerobic digester number 1.
If you think of this as a gas dome right here, essentially gas is extracted off the top of it and sent over here to the flare to be burned.
Oh, okay, I see that.
Yeah. In the very near future, that's going to be a cogeneration system, probably located right down here.
And it'll just kind of like take feed off of it or whatever.
Exactly.
Interesting. It's pretty cool. So there's always a little room for like improving, right?
Absolutely.
That's cool. Make it a little more efficient.
Mm-hmm.
And this can support our weight, obviously, right?
Yes, I hope so.
And then, well, how come this one's more domed than that one?
This was actually an earlier model. Those 2 were built in a different phase of construction. But those are larger, but they don't have this classic steel dome tank. That's a concrete tank over there. But it's the same principle.
Okay.
All this is getting mixed underneath us. So you don't feel it here, but it's getting mixed. It's getting turned over 6, 7 times a day, the entire contents of it.
And what are we coming up to right here?
There are actually 2 things in this building. One of it's the dewatering generator building. And so in the event that the power goes out, we'll deal with that first here. In the event the power goes out, we have the capability of completely going off the Edison line. And one of the things that we've done is we've always been on an interruptible rate. And what that does is saves the city about $250,000 a year by our ability to turn those on in the event Edison comes to us and says, hey, we're running short of electricity. And that happens very rarely, but you know, it's been a great deal for everybody involved, because we have to have, EPA requires us to have the generators here to do it anyway.
Right.
So on those rare occasions in which, you know, we're able to go off grid, helps Edison, and certainly the citizens pay less for electricity because of it.
Wow. Okay. Cool. So this would power the plant for how long?
You know, we can go days here with this. No problem. By that, I mean 10 days.
10 days?
I think so.
Good. Okay. So you're just checking out what's happening?
Mainly my job today is to run the belt press, and then what we're doing is we're dewatering the solids, and then they end up taking it up to button willow, and they use it for like non-food crops, alfalfa, cotton, stuff like that.
Okay. So you're just loading up the truck I see out there, right?
Right.